Welcome to my channel. In this problem, we're going to study what happens if we triple the distance between the two charges. How will it change the force of attraction or repulsion between the two charges if we triple the distance? So let's say we have the two charges Q1 and Q2, and these two charges are, let's say, positive charges, just an assumption. And these two charges are separated by a distance r. Now, keeping the magnitude of these two charges exactly the same, so these two charges are exactly Q1 and Q2. Now I have tripled the distance. If this is 1 meter, then I'm going to make it 3 meter. If this is 2 meter, then the distance will be now 6 meter. So the distance has tripled. What will be the force? Will it go up? It will go down, or it will remain the same? If it goes up, by how many times? If it goes down, how many times it goes down? So that's the thing we're going to calculate. And in order to calculate, all we need to understand is the Coulomb's law, or the force between the two charges. The force between two charges is given by this equation. That's the magnitude. So the magnitude F is given by this equation, where K is a constant. K, the value of K is 9 times 10 to the 9 Newton meter square per Coulomb square. Okay, so that's the force. So this force is for this condition now. Now let's calculate exactly the force again when the distance is tripled. So in this case, let's call the force is F prime here. So we call this as an F prime, and you can see here the force in this case, when the two charges are separated by distance r, we call that force to be F. And now when the distance between the two charges is triple, we call that force to be F prime. So the F prime in this case, it can also be given by the Coulomb's law. So in this case, we'll have K, Q1, Q2, and the square of the distance. In this case, it is r prime. And r prime is 3r square. So I'm simply going to solve this one. K, Q1, Q2, 3 square. If I do the 3 square, that's 9, and then r square. And I can take this constant out here, 1 over 9. Then I will have K, this Q1, this Q2, and r square. And this term here, this entire term, is exactly the force between the two charges when they are separated by a distance r. And you can see here, K, Q1 over Q2, K, Q1 times Q2 divided by r squared is the force. That's what the force is. So F prime, the new force, will be 1 over 9 of the original force. So that means the force between the two charges has been reduced by a factor of 9. So this we call as an inverse square law. So if the force is now doubled, if the distance is double, the force will go by 1 over 4th. If the force is now, let's say, by a factor of 4, if the distance has been increased by a factor of 4, then the force will be reduced by a factor of 16. That's how does the force changes. It follows the inverse square law. So this is it from this video. Do not forget to like, share, and subscribe the channel. Thank you very much.